Okay, we are in chapter 5.4. It is the second part of your lesson, even though it's two different sections. It's just all about what the graphs look like of polynomials. So yesterday we talked about what happens to the end behavior. As x is increasing, what happens to your graph, and as x is decreasing, what happens to your graph. It's output, when I mean what happens. So also, when the graph is increasing or decreasing, what x values are those? So today we're talking about their intervals of increasing and decreasing. It says when a function rises and then falls from left to right, it has a what's called a local maximum. I guess I could have put that on that line. So why is it called local? Because you might have a graph that has lots of maximums. It's not asking for the overall maximum. It's just saying as you increase and decrease, that's a maximum, that's a maximum, that's a maximum, that's a maximum. So it's saying in this area, it's local. It's just called a local maximum. Well, the same thing too, as you're decreasing, as it falls and then rises, it has a local minimum. The points on the graph of a polynomial function, so these points, or the, either the maxes or the mins, are called turning points. Different textbooks are going to have different vocabulary. So we could call it local max and local min. Some textbooks call it local maxima, local minima. Some call it a relative, because in that area, the relative area, it's a maximum or minimum. Okay, so you might see different things in different textbooks. Same with turning points. The one textbook we use at Barron, it's extrema, like extremes, highs and lows. So just be mindful, it might be called something different if you go to college or enter another class. But it's just highs and lows, okay? Functions change from increasing to decreasing, or from decreasing to increasing at turning points. Use a graphing calculator to graph and approximate any local maxima or local minima to the nearest tenth. Then find the intervals which the function is increasing and decreasing. So I'm going to use my graphing calculator, and I'm going to go to y equals, and I'm going to type this in here. Now, be careful, because you need to use the negative button for negative, not minus. And if you're like, how do I get to the third? Use the caret button, okay? Then you're gonna hit graph. If for some reason your graph doesn't graph properly, make sure that's the only equation in there. If your window is off, hit zoom, and go down to zoom standard, and it should give you your standard viewing window. See how this is, it's kind of like spinning, like it's loading. If you keep hitting enter, it will stop loading. So just be patient. And this is your graph. Kind of has this shape. It doesn't need to be perfect because we're writing the coordinates. Okay. Now I need to find the local min and the local max. So here's the thing. I don't need all of this graph. So I'm going to make my window better. I'm going to go to window. I don't need any negatives for y values. So I'm going to start it at 0. Okay, and I have all this excess over here and over here. You don't have to do this, but it makes it a lot easier when you're trying to find your max and min. So your x values, I'm going to go from -5 to +5. I don't need all that 10 to 10. That's just a little bit better. Okay, so I'm going to go to second trace, because when I hit second trace, I'm really talking about the calc functions here, and I'm going to calculate a minimum value. Now it says left bound, so I'm going to use my arrows and go to the left. And I want you to go to the left, like not too ridiculously far. Hit enter, and now it's saying, hey, what's the right bound? So go to the right of it, and what you're doing is you're telling the calculator it's in between here. And then your calculator wants you to guess what that minimum value is. And that minimum value is -1.09. comma 1.95. Now I'm only going to write the negative 1.09 because when we find an interval, I just care about the x values. My y values are increasing or decreasing. So it's saying y values increase or decrease, what were the intervals or x values given for increasing or decreasing, okay? So now we're going to do this again, second calc, and we're going to go to maximum, and you're going to go to the left of your maximum. I'm going to go to the right bound, and we're going to go to where we think it is. And our maximum value is 0.76, comma 8.3. Now I'm not writing 0.83 because the decreasing is the 0.83. It's the value. I don't want the value, I just want the x values. So here's what's happening. Don't look at this arrow, but I am going from here to here. I'm decreasing, then I am increasing, then I am decreasing. Okay? So, from way out here to negative infinity, my value would be up here. So as I go from here to here, I'm decreasing. Then from here to here, I am increasing. Then from here forward, my graph is decreasing. So as my x values go from negative infinity, so as I'm at negative 100 or so what, or so on, and I go all the way to negative 1.09, I am decreasing. And from negative 1.09 all the way up to 0.76, I am increasing. And then from that point on, I am decreasing. Notice I put a U for union, like and. Okay, so sorry, it's loud at school right now. Increasing and decreasing. So you're always going to hop back and forth. So you're never going to have decreasing, increasing, and then increasing again. That just doesn't even make any sense. So that's how you would complete that. Now, on the back, I don't know if it's on the back or the next page, you have these 4 problems. One of them's on your homework quiz. So that's how you're going to complete this. It says use the graphing calculator to find each function and find the local minimum and maximum. Estimate to the nearest tenth and then find the intervals. So let's start with number 1. If we graph that in our graphing calculator, we have x squared plus 2x minus 5. Graph it. Okay, and I don't like this viewing window. So I'm going to go to zoom standard. Okay, and all I have is one minimum. So second trace, you find your minimum. You're gonna go to the left, hit enter. You're gonna go to the right, enter. And what is this value? 0.99999 or negative 1. Comma, what is it? Negative 1, negative 6. And then I go through the x-axis a little between 1 and 2 and a little between negative 3 and 4. I don't really care about the intercepts right now because all I'm concerned with is maximums and minimums. Okay, so for you, I would just draw the graphs for now, find the maxes and mins, and then do the intervals. So here, I am decreasing and then I'm increasing. Notice, if I have 1 turning point, I have 2 intervals. If I have 2 turning points, I have 3 intervals. So you're going to have 1 more interval than you're going to have turning points. So I am decreasing from negative infinity to negative 1. And then I'm increasing from, okay, we're at negative 1. I'm increasing from negative 1 onward. Okay. All right. So you're going to do that with the rest of them. You don't have to do them on this sheet, but one of these is on that homework quiz that you owe me. All right, on the back, let's recap now the past 2 lessons. It says, what does a local maximum or minimum occur, or when does it occur? Okay, it occurs when the graph changes from increasing to decreasing, or vice versa. Okay. And then it says, describe the end behavior of the following functions. This was yesterday's. Well, if it's x to the 6th, that's going to mimic a parabola. There's probably lumps and bumps, but we just care about the end behavior. F of x is hitting infinity, both. Here, normally x cubed looks like this, but it's negative, so it looks like this. So the left side's going to positive infinity, and the right side's going to negative infinity. So here, as x gets bigger, or as x gets smaller, both your f of x's are going to positive infinity. And as x is getting bigger and as x is getting smaller, or approaching, that arrow means approaching infinity, you're going to negative infinity, and then the opposite positive. Okay, so that's just a little recap of the past 2 days. And then down here, if you want to try it, you can. Take out a GCF here and factor, unfoil a factor, x squared, minus minus. Here, if you can't factor it, which maybe you can, then grab this in the graphing calculator. See where it crosses. So 2x to the 4th plus 3x squared. Now here's the thing, maybe you could factor it. You can still do this. You can do it for all of them. Oh, I see I cross at, zoom in. Those aren't pretty numbers. Maybe it's like a half. So let's try it. Does a half work? 2, 0, 3, 0, negative 2. Drop the 2, 1/2. 1/2, 2 1/2, or 3/2. 1/2, no, that's not gonna work. Okay, so use the rational root theorem, but let's see if we could just factor this like normal. Two x to the 4th, check. 4, I want that to be positive, minus 1, yep, that works. So what you're gonna do is you're gonna get 2x squared equals 1, x squared equals 1/2. You're gonna take the square root of both sides. It's gonna be root 2 over 2 and negative root 2 over 2. I could just do that in my head, rationalizing it. And here, negative 2, take the square root, you're gonna get positive and negative I root 2. So we wouldn't have been able to see that in the graph. We tried a half, that doesn't work. You could try the numbers for the rational root theorem, that doesn't work. You had to have factored, okay? The rational root theorem won't work every time, it works most of the time. And then synthetic division, use 3 in the box to show that this is a solution, and then find all the factors. So this is a nice little review for you to work on, okay? This is it, that's your last lesson. So when you're done with this video, make sure you're done with your review, okay? And your test is gonna be Tuesday, Wednesday if you're in class. Your test is going to be Monday if you're 100% virtual, okay? If you have any questions, please email me.